Audio Jungle. Audio Jungle. Audio Jungle.
Hello and welcome to the first Radical Geek demonstration on acceptance test driven development with me, Mark Jones. In this presentation we're going to talk about a few different things. We're going to talk about what ATDD or BDD is. We're going to talk about what a process to perform ATDD in your development environment might look like. We're going to talk about how to set up projects for testing MVC for web applications using an ATDD process. We're going to talk about the tests themselves, and we're generally going to cover a broad range of what it might look like to set up an ATDD process in your environment. Okay, so first of all, let's talk about what acceptance testing is. Okay, so in the context of ATDD or BDD, acceptance testing is all about defining the requirements before we start writing any code. We want to be able to get our requirements from our business users in a language that everybody understands, a shared language that describes the business domain or the way that our users of the system might perform. And for that purpose, we're going to be using Gherkin syntax to describe our acceptance tests. Our acceptance test, our business description is only part of the equation, though. We also need to ensure that we can run these tests in an automated way that can validate for us whether our acceptance criteria have been met or not. And so this is all about being able to write our tests in both a way that the business understands and in a way that's automatable. And of course, why would we have acceptance testing? I think we've really covered this, and anybody that's going to be watching this video should probably understand by now that acceptance testing is important to understanding that our system works in the way that our business requires it to, the way that our users expect it to. And it's a way of ensuring that we're only developing the functionality that is valuable to our business and the functionality that's needed. Okay, so what could an ATDD process be made up of? Well, first of all, like I say, we need to define our acceptance criteria before doing any work. We need to be able to run our tests and prove that our criteria have been satisfied. We need to understand that our acceptance test can also be considered a form of integration test, in that an acceptance test is going to cover a number of different parts of our system and check that those parts of the system are integrated with each other. An integration test can be many other things as well, of course, but an acceptance test can be considered a form of integration test. And we want to talk about how our tests can be written in plain English, as I say, in a language that anybody can understand, and in particular the people that are writing the tests and defining our requirements, the business users. Okay, so let's have a look at an example process. It all starts with a business user. The business user describes his requirements in a way that is defined and that we can all understand. For this, I like to use Gherkin syntax. Gherkin syntax for a user story is described in the format that you can see there. In order to do a particular thing, as an actor on the system, I want to be able to perform a particular action. Business analyst needs to come right away and understand these requirements, gather these requirements, and talk to the business user about what he requires in his system and try and describe them in given when then syntax, which would describe our use cases. So given a particular scenario has occurred or the system is in a particular state, when I perform an action, then I expect a particular outcome. And this is fairly synonymous with the arrange, act, assert padagram that you find in unit testing. And the business analyst is going to have a conversation now with the business users and try to define all the requirements that the business user has. And it's going to write each of these down, and they're going to become the tickets that make up the product backlog. Okay, so once we've got a product backlog, we have a number of tickets, and each ticket is a user story with a number of use cases, and these are synonymous with the SpecFlow implementation, which uses the terminology of features and scenarios. And these, like I say, are the user stories and the use cases. The quality analyst now needs to come along, and he needs to think of the edge cases, the corner cases, the unhappy paths that the business user and the business analysts aren't really trained to consider. Of course, they'll come up with some of them, but the quality analyst now needs to really look at the system in depth and the requirements that have been passed to him to really figure out exactly what else could happen in the system. So the quality analyst defines some additional requirements. Once we've got the product backlog with a number of requirements and defined, we need a cross-functional team of people, everybody that's involved in the process of developing the software, and together they need to start estimating the size of each of these requirements, each of these use cases. And once they've estimated the size of each of those use cases, they can estimate the size of the features. And based on those decisions, they can start pulling in the tickets that they want to do in this particular sprint. But the people that should make the decisions about pulling the tickets in for the sprint are only a sub-selection of the cross-functional team. They're the people that are involved in the business decisions on day-to-day processes and, of course, the successful delivery of the project. And in their discussions, they're going to select the tickets that can make up the first sprint backlog for the work to begin by the developers. And so a developer comes along and he picks up his first ticket, and then he enters into the acceptance test-driven development cycle. The first part of which is writing the failing test. Now the test has already been defined for him in Gherkin syntax, and using SpecFlow he can automate that requirement by using various implementations, be that by writing a number of unit tests, as we can see in this example, or it may be that he writes a user interface acceptance test that runs later on. When he's writing a unit test, he goes through a sort of inner cycle within the acceptance testing cycle. As he's written his failing acceptance test, he starts writing failing unit test, and then he goes around the red-green refactor cycle to write a number of unit tests until the acceptance test is passed, until the feature is complete, at which point the system is automatically deployed and the ticket is checked back in. So the code is all committed to source control, and the automated builds run, and the tests are all checked, at which point the engineer is free to pick up the next ticket and go through the process again. Once the engineer's completed some tickets, a quality analyst is going to come along and he's going to pick these tickets up and check that the functionality that was originally described has now been implemented. And he's got a number of tools to do that. First of all, he's got the test labs that have been automatically deployed when the developer committed his code. And of course, he's got the reports from the nightly builds, from any of the builds, in fact, when the test runs are available to him so that he can check to make sure everything is as it should be. If he's happy with it, then the application can deploy to the next environment, and once obviously it's been tested by the users, it can deploy to the staging or pre-production environments and on to production. At the end of the sprint, when all the tickets are completed, the cross-functional team can gather once again and they can start to analyse the outcome of the sprint. They can hold a retrospective meeting. And in that retrospective meeting, they're going to analyse the success of the changes that they've implemented in the sprint. And that can be via a number of things. It can be by metrics, it can be by just simply how efficient they've been, by the velocity of the team. But in general, what they want to do is they want to try and find things that they can do to refine their process and ensure that they're getting better and better as they move along. So how do we get this all set up? Well, first of all, we need to make sure that people have been trained in the roles, in the skills that they need to perform their roles. And this means that in the first stage, we need to make sure that the business analysts, the business user, and the quality analysts all learn to use the given when then syntax to describe the user requirements. That way, we can ensure that everything that is described at the beginning of the process is what's ultimately tested at the end of the process. They need to be able to start thinking of things like edge cases and corner cases too. They need to get better at thinking about how to describe the requirements of a system using the given when then syntax. The second step is to get the quality analyst, the engineer and the architect together, and they need to understand how to write code test first. They need to get into writing test before they write any of their production code, be that the acceptance tests or unit tests. And they need to understand how to create test projects and maintain them. There are a number of challenges around testing different parts of the application. User interface is tested using user interface tests, of course, whereas obviously the service layer is going to be tested primarily with unit tests, integration tests, and acceptance tests. And they need to be able to follow known design patterns to do that. not only do known design patterns allow the system to be more testable, but it means that other developers coming onto the project can pick things up quicker. And these patterns have been defined over a number of years, and following these best practices does generally make your system better. I can't stress enough just how important it is to learn from the mistakes that others have made in the past and to try to produce the best system that you can. And part of that is writing your code test first. Step 3, the project manager and the quality analyst and the engineer, well, together they need to ensure that there's an infrastructure in place, that the systems are available, that we have the testing servers, that we have the build servers, source control servers to be able to run all of this stuff. And of course, we need to learn how to collect metrics. There's no point in having all this stuff in place if we're not learning from it. We need to be able to ensure that not only are we collecting metrics on our development process, but also on our user experience and on the success of the changes. It's always important to understand what it is that we're trying to change about the system and have a way to validate that that change has been successful. We need an environment too, and the environment's very important. In this scenario that I'm going to describe in a moment during the demonstration, we have a TFS server, and we have a testing server, and we have a number of test machines. The TFS server is unlikely in a real-world environment to be made up of a single server. Generally, you would have it spread across a number of servers with build servers, lab management servers, and things like that out on other physical or virtual boxes. The test server, again, is also either a physical or a virtual box, but in general, it's going to host the application that we're going to test. So TFS needs an automatic way to be able to deploy to the test server. In the case that we're going to describe in a moment during the demonstration, the test server also hosts the database, and the database is going to be deployed automatically using Entity Framework. The test machines are the environments that we're going to want to test our application in. So in this case, as a web application, we're going to want a different collection of browsers and operating systems to be able to connect to our application and test it. And so we can see that in action. When we check our code and a build runs, it deploys to our test server, it sends a signal to our test machines, which then run a number of operating systems to test our test application. And of course, all those test results are reported back to TFS. And here's an example in Visual Studio of our use cases. We can see here that we first of all have our user story described in order to as a I want. And then secondly, we can see that we have our use cases, and these are our SpecFlow scenarios. And these have a number of characteristics. We can see that we're able to pass tables of information to our tests. We can see that we've got variables in our steps as well. We can see that we've got a number of additional steps like AND steps that allow us to more accurately and thoroughly describe the system under test. And we can see that we've got these browser tags that allow us to define that a test should be running in a collection of different browsers. Okay, I think it's time for a demonstration. Okay, so here we are in Visual Studio. This is an example project called the registration form, which is simply a default MVC for web application, and we're going to test the registration form that comes with the application out of the box. I just want to go through a few things that I've got set up here that enable this whole acceptance test driven development project or demonstration to work. First of all, I've got my virtual machines running in the background. I've got a TFS server running locally that I'm connected to here. This team project collection is purely for testing this, purely for hosting this project. I've got two test servers there, test host and test node. They're my Selenium grid. So I have Selenium WebDriver installed on both of those, or Selenium Server Standalone, which is a Java application, and they're connected together to test my web application by running browsers against it. And my web application is hosted on the final virtual machine there, test web. And the web application, of course, has a back end to it as well. It has a database, and that database is hosted on that server too, and is deployed when the web application is deployed to it using Entity Framework. So Entity Framework is capable of creating the database or upgrading it as necessary on that web application, on that web server when it's deployed. I also have a number of things installed on my computer which enable me to give you this demonstration. First of all, I'm using the NUnit test adapter, which allows me to see NUnit tests in Test Explorer. I'm using NUnit to run my Selenium tests, my SpecFlow tests, because purely because it gives me a few more features. There are more available extensions through NUnit than there are through MS Test, and I'll come to that in a moment. The other thing is, of course, SpecFlow itself. It's not much point having our SpecFlow tests if we can't run them. Okay, so the reason I'm using NUnit is because of some of the libraries that we have loaded in this acceptance testing project. As you can see, I've got SpecFlow and Selenium WebDriver, but I also have a few SpecFlow add-ons. I'm using SpecFlow Dynamic Assist so that I can pass table data from my tests easily as dynamic objects, and I'm using this SpecFlow contributed base class, which allows for the multiple browser testing that I'm going to demonstrate to you. Okay, so let's have a look at the acceptance test project itself. First of all, we have our feature file. The feature file contains our user stories and use cases. We described this a little bit in the presentation. You can see our tables there, and if I move down the file a bit, you can see our variable that we pass through. This test has a number of steps in it. Each step is defined in the steps file that we have here. Once we've defined a step, it can be reused and is available through IntelliSense in our feature definition file, which means that people like testers and business analysts can get involved in the definition of these steps in Visual Studio directly, should they wish to, or should the company allow it. But it allows us, to more easily think of things like the failing tests, the unhappy paths, corner cases, edge cases, and things like that. The developer shouldn't really be responsible for dreaming up all of these different scenarios and implementing them through this code, although the developer may receive this, the features from elsewhere and implement them in the file as necessary. But I do believe it's handy if the testers have access to this too. And that IntelliSense from the steps file is what makes it possible. Each of these given when and then steps is bound by these given when and then step definition tags that we have at the top of each of our methods. And these methods in the step file basically say how to perform that step. And in most cases, they are going to exercise the page object model, which is a pattern that we're using in our acceptance test project to allow us to test in a very conceptual way. It allows us to think of a page that we want to test and define all the properties of that page that we want to be able to use in our tests. And so let's have a look at that. You can see straight away that we've got a couple of different pages being used here. We've got an index page and a registration page, and each one of them is calling methods such as checking that an element exists or populating a text box under the element with some information. These page objects, like I say, are a class that represents the page under test, and they each have a fairly standard setup. We have a number of properties at the top which have these bindings to how we're going to identify a particular element on the page. So you can see here that we're identifying an element using its ID. And then we have a number of methods that exercise the functionality of those web elements. So it may be that we send some keys into a text box, sorry I had to slip it there. Or it may be that, for example, we click a button. And this is how we make it easy for not just developers but everybody else to understand exactly what's going on in these acceptance tests. It's pretty easy once a tester gets the idea of this to pick this up, and lots of testers these days are getting more and more into the code, and I think that's a good thing. Now this is a reference implementation, as I said, and I'm going to make this code available on GitHub, and the important thing in here is how this is set up. These text fixtures and base classes in here are what make everything fit together. It's how we bind all of the libraries that we're pulling in to allow us to do things like test on multiple browsers. Okay, so I've said, of course, that we're testing a standard registration form and that there's only been a single change made. Now, to run these tests, we need to make sure that our web server is running. So before we do any acceptance testing in Visual Studio, we always need to make sure that we're running the application. So I'm just going to fire that up now so that the web server starts, the IIS web server down here. And then I'm going to just happily close that. Now we saw straight away from that we're looking at a standard application. Okay, so let's go ahead and run some of our tests. You can see here I've got a test that passed on Chrome. Now that's, like I say, an implementation of that SpecFlow scenario that's running on a particular browser. So if I go back to this SpecFlow scenarios for a moment, you can see by the name the user signs up with valid details and the various browsers that we want to run it on. So we can see just down here, we've got the user signs up with valid details on different browsers. So let's go ahead and run that one on Firefox, for example. Okay, so we see it build, and then hopefully we see a web browser start up and run our test on our test web server. Soon, of course, the test doesn't fail. There we go. And our test's passed. And of course, we can run that on a different browser as well. We can run the same test if we want to on Chrome. And it's important that we have this ability to run our tests locally on our machine as we go through the acceptance test-driven development cycle. We have failed a test. It's important that we have these available on our machine as we go through our test-driven development. The reason for that is, of course, that we need to be able to ensure that things are working. We don't want our tests to be failing all the time. And so, as we go through our test-driven development, not only do we implement our acceptance test, but of course we have a unit testing project too. Not every acceptance test is simply checking that the colour on a page is correct, and we often need to go down into our services and implement functionality there too. So it's important that we have unit tests in place to drive our test-driven development as we go. Often though, we don't necessarily need to make a change in our unit tests. For example, in this particular test here, move down a little bit, what we're actually checking for is that the password confirmation and the password that we've entered into the two text boxes match. And we can see here that we have sent some invalid values, and we're going to check for the existence of the error message on the page. And so this, in effect, is a failing test, or it's testing a failing scenario, but the test itself, of course, is going to pass when we run it. So let's have a look at how we would make that change in our registration form. Now, of course, this is just simply a label, and we can change our labels on a MVC application on our models. So when we look at our account model, if we have a look down, we can see that this is where we're going to set the error messages for our login model. So if we have a quick look down here, we can find the place where we need to check to see whether the password and the confirmation password match. And you can see that we've got the same text in here. Okay, so that's our tests running. Now, of course, as we went through the process of doing our development, the next thing that we would want to do would be to check in our code to source control. So let's go back to Source Control Explorer for a moment. Okay, so in Source Control Explorer, we're going to run our gated build. And as we check our code in, our gated build is going to run every single time. And our gated build is going to run our unit tests first. Our gated build is not going to be concerned with our acceptance tests, and there's a good reason for that. And that's basically because as we run our tests and as we scale them up using multiple browsers, we're increasing the amount of time that our test run is going to take. And so what we want from our gated build is quick feedback. We don't want developers sat there waiting for a long period of time for acceptance test builds to finish before they can see whether their changes have been validated and continue on with the next task. And so for that reason, we run our acceptance tests on night build. We do, however, deploy our application once we've built it. So our automatic deployment build that we have here, our build template, will be used as part of our gated process to deploy the application to a test server. You can see here we've got a copy of that template that includes the ability to run NUnit. The reason that we want to run NUnit is because, as we say, our SpecFlow tests are run in NUnit, and furthermore it's because we're running TFS 2010. Because I'm using virtual PC to host my virtual machines, I'm unable to host a 64-bit operating system, which means that I can't go above TFS 2010. Of course, on TFS 2012 and above, NUnit is supported by default, so we don't need this additional build template. Okay, so let's go ahead and run our gated build and run our unit test. In fact, let's not bother with our gated build. Let's move straight on to our acceptance test build. Well, imagine that our gated test build ran fine in the night, and instead we're just going to go ahead and run our acceptance test build. The point of running our acceptance test build is to run the acceptance test, of course, and to run our acceptance test, it's going to need to deploy the application to our test server. So let's have a look at our test server and see whether we've got a version of the application already installed. Oh, looks like my test server shut down at some point. Okay, so on our test server we can go and have a look in Internet Information Services. We see we've got some sites. Now our web deployment package isn't going to create the site, but it will populate the site. So if we have a look in here, we can see that we've got some files. We can go ahead and delete these if we want to. I don't have to delete them, they would be replaced on the next deployment. But just to prove the point, I'm going to go ahead and delete these files. And I'm not going to stop there either. I'm going to make sure that everything's gone from this server. And I'm going to go ahead and I'm going into SQL Management Studio. And in here we should find a database for our registration form. But again, I'm going to go ahead and delete. Now we use an Entity Framework with our default web application, and so Entity Framework will create this database upon the application deployment. I have a post on my blog from some time ago that goes through the process of setting up Entity Framework for deployments to different environment types. Of course, each environment has its own requirements as regard to whether it needs a new database creating or whether it needs a database upgrading, whether it needs seeding with data or whether it's got existing data. And so there's a lot of different scenarios that your Entity Framework implementation needs to be able to take into account to effectively deploy your application to each environment. That's of course assuming that you're using Entity Framework. If not, keep an eye out for further blog posts on how to do database deployments using Visual Studio 2010 database templates. Okay, so I've gone ahead and I've deleted my application from my server. And of course I'm also running my two test servers. And for the purposes of this demonstration, I'm going to actually log into these test servers. And these are the servers that are hosting my Selenium grid. And I can show you what that looks like. Each server has its own configuration file, which sits at the moment on the desktop. You can see there I've got node.js, and that's because this server is my node server. Sorry about that, I didn't mean to make it full screen, but oh well. They've all shut down recently. And actually I'm going to need to go ahead and start up my server here. So I've got a command that I have available on my system. I should have set this up really on a batch file, but for the purposes of this demonstration I've just been leaving it running. It looks like it's going to let me down at the last minute here, so let me just go ahead and get this server up and running. In fact, before we start the node, it's probably sensible for us to start the host, isn't it? So let's log into the host server 2. In fact, this is actually a good opportunity for me to demonstrate to you exactly how this is set up. You see, the command that we're running, if you have a look at it as we go, let's have a look at our command. And you can see that we've got a hub and a node file here, and that's because the hub doesn't actually run anything by itself, but it needs nodes to connect to it to exercise the browsers. So first of all, I'm just going to start the hub. And you can see here that we're referencing the Selenium server standalone Java file, and also we're passing in a hub configuration file. So let me just execute that to start up our hub. And now open up another command prompt. As I said, this is probably better done through batch files or starting it as a service, something like that. And the node is pretty much the same as a hub. Again, you start in the server but as a node, and you pass in a node configuration file. The node then connects to the hub and everything's good. And let's go back to our other server, our test node, start that one up as well. And the reason I'm doing this is because I want to show you that we've got a number of servers running that have got different browsers installed on them. And these could be different platforms, they could be Linux machines, they could be OS X machines. They don't have to be virtual machines, they can be physical machines too. I'm just going to arrange these a little bit so that we can see two at a time. Okay, so we can see them both quite easily now, despite my small screen size. And I'm going to go ahead and run that night build. Okay, so the build's running, or it should be queued. There we are. Okay, so while the build's running, the build will be deploying the application to the test server, and also it will be running the acceptance tests on the Selenium grid. So let's have a look at the Selenium grid we've just set up. We'll have to log in again, of course we will. Now we can see already that the drivers are running. You can see there that Safari is open and we're exercising our test. And you can see that Internet Explorer is running on the test host. So we've split the browser testing across a number of machines here. So as we've suggested before, we can test multiple browsers across multiple platforms. The only thing that really limits you to how many browsers and platforms you can test is your available hardware. I obviously recommend that this is done using virtual machines on something like an ESX server or a networked Hyper-V server. Just going to wait now for this test run to finish. You can see that it's going through the tests and running each of the 2 tests that we've got in all 4 browsers. Okay, the test run is finished. And if we go to the test web server, and we have a look at our web application, we can see that it's redeployed the files that we need to run the website. And of course also if we go back to SQL Management Server, again we can see the database has been deployed. Excellent. Let's have a look at our test run. We can see that our test is passed, our build has passed. And of course we can see our test results as well. A few warnings there we need to address. Have a look at data loops. Let's get rid of them. What's the tests? There we go. 2 test runs completed. So that suggests that we've run 2 test runs, one being the unit tests and one being the acceptance tests. And you can see the difference there. We've got the unit tests, 3 default unit tests that came with our unit testing project, and we've got our 8 acceptance tests. And we can load that up and have a look at our test run, see whether we've got any failures. Of course, it would indicate to us any failures in the build. And of course, we can fail the build on the failure of tests. But you can see there that we've got a separate test result for each of the browsers. We can see whether a test has worked on a browser or whether the test itself has failed altogether. And that's quite important to note that you've got a separate test result for each test, because of course we've only actually defined the test once in our acceptance test project and use the browser tags to scale that out to each browser. So there you have it. The build is run. We've got an acceptance testing build that runs on a nightly deployment. The only other thing I'd like to show you, which isn't really related to the acceptance testing, but is the versioning. And the versioning is quite important. I said earlier that we have a build definition. If I go back to Source Control Explorer, we have this build definition where it says it has versioning with it, and we can see that if we look at our build template. Okay, so sorry, let's add the build definition instead. If we look at our process, we've got a custom process here, custom build templates loaded. And we can see at the bottom of this window, we have assembler versioning. And the idea here is that we set the major and the minor version number at build time. So we have in our source control a main branch. If I have a look at my registration form project, we have this main branch. And on a branch for release, we would create a new branch with a name such as 1.0.x.x. And then in the build template, we would set the 1 and the 0 as our major and minor version numbers. And then the build would take care of the build and revision numbers. The build number would be the number of days from a given date, so it might be something like 532, and the revision number would be the number of times that that build has run on that day. And that gives us a good unique version number that we can use to ensure that we know exactly what we've got in what stage of our deployment process. And we can always go ahead and look at that. We can go back to our servers, and if we go and have a look in our registration form, find our own assembly. Let's have a look at the properties of this assembly. And there you have 0.1, the version of the build template as we've just seen, a number of days from a given date, and it's the second time that this build has run today. And so there you have it. That's an acceptance testing process with automated acceptance tests using Selenium in Visual Studio 2012 to test a NVC4 web application, testing it using Selenium Grid and scaling our tests out across a number of browsers and platforms. I hope you've enjoyed this first Radical Geek presentation, and I hope to do many more. So thanks again for watching. Goodbye.